The fundamental theorem of calculus. Made easy. What is the fundamental theorem of calculus? It is what is called a definite integral, which is the integral of a function given a certain interval, which is listed as a and b here. What does it mean? What the fundamental theorem of calculus does is calculate the area of a graph under a certain interval. The points a and b can be thought of as points on the x-axis as shown here. Let's go over a quick demonstration. Looking at this graph, we have the graph of y equals 2, which is just a straight line. Let's say we wanted to find the area from 0 to 2. Well, that means our area is going to be this shaded region over here, like that. We know this is just a square, and the area of a square is simply just length times width, which in this case would be 2 times 2, which is equal to 4. What the fundamental theorem of calculus says is that we can also find the area under a curve by using it. Here is the fundamental theorem. Let's go ahead and write this down for our problem. So we have the integral, and our interval is from 0 to 2. F of x is simply what y is equal to, which is 2 dx. Let's go ahead and solve. This is going to be equal to, the integral of 2 is just 2x. And now for the notation, this is how it goes. We write down our brackets, and then on the bottom is where a goes, and on the top here is where b goes. Now the fundamental theorem says that you can find the area with f of b minus f of a. F is just what our integration gives us, which is 2x. Therefore, we have 2 times our b value, which is 2, minus 2 with our a value, which is 0. And when we go ahead and simplify this, what we'll have is 4 minus 0, which is equal to 4, which is the same exact area that we got earlier. Let's go over some examples. Example number 1. We want to find the definite integral of this function here. What we do is we start by taking the integral of this inside function here. If you need help taking integrals like this, click on this link. I made a video on it. The integral of x squared minus 3 is going to be x cubed over 3 minus 3x. And now whenever we're doing definite integrals, this is the notation that we work with. We're going to put our a value, which is 1 here, and our b value, which is 2 up there. What we do first is we'll start with this 2 up here. We're going to plug that 2 into every x inside. So what we'll have is 2 cubed over 3 minus 3 times 2. This section right here represents f of b. Now what we have to do is subtract that by f of a. So now we look at the bottom interval, which is our a, which is a 1, and we're going to plug that 1 into every x inside. So that is going to become 1 cubed over 3 minus 3 times 1. What we do from here is simplify. 2 cubed is 8, so we'll have 8 over 3 minus 6 minus 1/3 minus 3. Simplifying further, what we're going to have is 8 over 3 minus 18 over 3 subtracted by 1/3 minus 9 over 3. From here, the left bracket is going to give us negative 10 over 3 minus negative 8 over 3. Now, all we got to do is simplify these, and in simplifying this, what we're going to have is negative 2 over 3. And that's going to be our final answer. Here's a visual of the problem we just solved. You can see that the red line there is the graph of our function, which is x squared minus 3. Our interval is going from 1 to 2, and then our area, which is negative 2/3, is that shaded region right there. This is the basic principle of what the fundamental theorem of calculus is helping us calculate. Example number 2. We want to find the integral of secant squared with our interval going from 0 to pi over 4. This might look complicated, but if you were to look at your formulas, secant squared, the integral of that is just tan of x. So our integral becomes tan x, and our interval is from 0 to pi over 4. Now all we do is solve this. So our b value, which is the pi over 4, goes first. That's our f of b. We're going to have tan of pi over 4 minus f of a, which is going to be tan of 0. Tan of 0 is just 0, and tan of pi over 4 is 1. So we'll have 1 minus 0, which is equal to 1. And that's going to be our final answer. Here is the visual of what we just calculated.